Alright, hey guys, so this lecture video is covering the first section of Chapter 6. Chapter 6 is all about inverse functions and relations, and Section 6.1 is kind of reviewing operations on functions. This beginning is going to be review, so we'll move kind of quickly through it. But just a little warm-up here to kind of help us review how we add and subtract and multiply different polynomials. We've been doing this in Chapter 5. Whenever we're adding polynomials, you want to add like terms. So I would just do 2x squared plus 3x squared to get 5x squared. Then I could do the x's, so 3x plus negative 5x is going to be negative 2x. And then negative 8 plus negative 7 is really just negative 8 minus 7 would give us minus 15. And that would be our final answer. Hopefully you guys remember doing this. So we're going to move right along. Number 2, we're multiplying a binomial times a trinomial. And this is basically kind of like extreme foiling. And everything in this polynomial needs to be added to everything in that polynomial. So basically we can think of multiplying this x by everything first, and then we'll do the y. So x times x squared is going to give us x cubed. X times negative 2xy is going to give us negative 2x squared y. And then x times y squared would give us plus xy squared. And now that we've multiplied x by everything, we're going to do the same thing but with the y. Y times x squared, well, that's going to be plus y times x squared, that's going to be x squared y, so we keep it in order. And then y times negative 2xy is going to be minus 2xy squared. And then y times y squared is going to be our y cubed. So then to clean this up a little bit, we're going to combine like terms. Nothing else goes with the x cubed, so that's going to stay the same. And then we have minus 2x squared y plus x squared y. So we can think of that as a plus 1x squared y to get us just a minus x squared y. Negative 2 plus 1 is just a negative 1. And then just kind of keep moving down the line here. Xy squared minus 2xy squared, so that's 1. Xy squared minus 2xy squared to give us a negative xy squared. And last but not least, we got our y cubed. Nothing combines with that, so we'll have a plus y cubed at the end. And that would be our final answer. And those are the little bit more difficult ones. You just really got to take your time, focus on what you're doing, be meticulous in your work, and then combine like terms. And this one was harder because it had x and y's and not just numbers. So they will tend to be a little bit easier than that. And then down here, we have number 3. It's just a division problem. It's a fancy way of writing division problem. So I'm going to rewrite this actually. So we have 14x to the 4th y over 2x cubed y to the 5th. Because hopefully this setup right here reminds you, oh, dividing means we subtract our exponents. So I'm basically going to look at this like, okay, well 14 divided by 2 is 7. Divide your numbers. X to the 4th divided by x cubed, well 4 minus 3 is just 1. So I'm left with an x. And then since there's no number here, this is actually a y to the 1st power divided by y to the 5th. 1 minus 5 is negative 4, so we have y to the negative 4th power. And then to actually get this in like most simplified form, a negative exponent always moves to the denominator. So basically we're going to take this guy and move it to the denominator so that we have 7x over y to the 4th. And once you move it to the denominator, you lose the negative. And that would be your final answer for that one. So hopefully that kind of was a little bit of a refresher. We have lots of exponent rules And there we have talked about this before, but that was just a little refresher. So then moving on to what we're learning new in this section, I have a little table here for you. And basically, it's all the stuff we've been doing, just kind of a new notation. If we're adding functions here, so we're going to start seeing it written like this, f plus g of x. And it just means you add the two together, like we did in the last warm-up. Subtraction, subtracting, we're just subtracting. Multiplication, same thing we just did right there, just multiplying the two together, and then division. All the same operations we've been working with, just written a new way. And so this beginning of this lecture, we're going to just work with problems written this new way. So example 1. Add and subtract functions. So given that f of x equals x squared minus 4 and g of x equals 2x plus 1, find each function. Well, we have f plus g of x, and that's really just f of x plus g of x. And if I rewrite that, well, f of x is x squared minus 4 plus g of x, 2x plus 1. And it turns into the exact problem we just solved in the last slide. You add your like terms. Nothing else can add to the x squared, so we would have x squared. And then nothing can add with this x right here, so plus 2x, and then negative 4 plus 1 minus 3. And that would be your answer right there. And then very similar over here for the subtraction, this is just f of x minus g of x. So we would have x squared minus 4 minus 2x plus 1. Well, x squared minus nothing else, x squared still just x squared. And then a 0 minus a 2x is going to give us minus 2x this time. And then negative 4 minus 1 is going to give us a negative 5. So subtraction's a little bit trickier because you kind of have to distribute that negative sign in, or just think about it as you're subtracting it to get that this is a minus 2x. That was kind of the tricky part there. But we have been doing this a lot, so hopefully this wasn't too bad. Why don't you guys go ahead and hit pause on the video and give this example a go on your own. Come back when you're ready to check your answer. All right, so just kind of rewriting this. This is going to be f of x plus g of x. A little bit longer polynomial here, but we still just have x squared plus 5x minus 2 plus, in parentheses, 3x minus 2. Well, we're going to have x squared, 5x plus 3x plus 8x, negative 2, plus negative 2 is kind of like negative 2 minus 2, minus 4. There's our answer for our first guy there. And then the subtraction problem, this guy just turns into f of x minus g of x. So we have x squared plus 5x minus 2 minus 3x minus 2. Well, have nothing to subtract from the x squared there, so it's just x squared. And then 5x minus 3x, okay, minus 2x. Then negative 2 minus negative 2, that minus a negative changes to a plus. So then negative 2 plus 2 is just 0. So then technically, to make this in like simplest form, your final answer would just be x squared minus 2x. You don't need that plus 0 at the end. If you were doing anything online, like in Delta Math, that plus 0 is going to give you an incorrect answer. So there's your final answer for those. And that's the addition and subtraction. Again, we've been doing a lot with that. Really just combine like terms is all it is. Whether you're adding or subtracting, just combine your like terms. It gets a little bit trickier when we get down here to the multiplying and dividing. We'll just work through it together. So then just like we did with addition and subtraction, this is just f of x times g of x. So I have x squared plus 7x plus 12 times x plus 4. And basically I need to multiply everything in this guy by everything in that guy. So I'm going to take this x squared and multiply it by both of these first. So x squared times x is x cubed. X squared times 4, 4x squared. Then I'm going to use the same thing with the 7x here. 7x times x is plus 7x squared. 7x times 4 is plus 28x. And last but not least, use it with the 12. We'll have plus 12x. And then 12 times 4, 48. Plus 48 there. And then combine like terms. Nothing else goes with the x cubed. So we got an x cubed there. And then we got 2x squared terms here. 4 plus 7 is going to give me plus 11x squared. Right here, 28 plus 12 is going to give me 40. So then plus 40x. And then plus 48 at the end. Nothing else to combine there. And there's our final answer. Again, we've done multiplying like this before, and that's why I'm going through it so quickly. Email me if you're getting stuck, but hopefully this is kind of help jogging your memory. And then over here, back to dividing. I know we like dividing polynomials, just kind of rewriting this. We have f of x divided by g of x, or we could think of it as f of x divided by g of x, whatever way you prefer. So what's that going to look like? Well, we have x squared plus 7x plus 12 divided by x plus 4. And we know that dividing polynomials isn't so easy like multiplying or adding or subtracting. We know we can use synthetic division to do this, or long division if you prefer, but I know most of us prefer synthetic division. So in our little box right here, we take the opposite of this, so we would put -4 in our little box. We would take down our coefficients. We know there's a 1 right there, so it'd be a 1, 7, and a 12. And we draw in our arrow, bring down the 1. We multiply, -4 times 1, it's -4. We add going down. 7 plus -4 is going to be 3, kind of like 7 minus 4, 3. We multiply, -4 times 3, -12. We add 12 plus -12, 12 minus 12 is going to be 0. So we don't have any remainder, which is nice. So then writing our solution, since we started with x squared, this is just going to be an x plus 3. And that would be our final answer there. So again, all the skills we've learned back in chapter 5, just kind of a new notation of how it's written. So go ahead and hit pause on the video and try this guy on your own. Come back when you're ready to check your answer. All right, so back to multiplying here. We got f times g of x, which is just f of x times g of x. And so we have x squared minus 7x plus 2 times x plus 4. And just like we did before, we're going to take everything in the first and multiply by everything in the second, kind of extreme foiling. X squared times x is x cubed. X squared times 4 plus 4x squared. Move on to my next term here. -7x times x is minus 7x squared. -7x times 4 is minus 28x. And last but not least, multiply the 2 by everything. 2 times x is plus 2x. 2 times 4 is plus 8. And then last but not least, we combine like terms. We're going to have x cubed, 4 minus 7 minus 3x squared. -28 plus 2 minus 26x. And then plus 8. And that would be our final answer there. Hopefully you guys were able to get that on your own. And then the division problem over here, this is just f of x divided by g of x. So we have x squared minus 7x plus 2 divided by x plus 4. And if we're using our synthetic division here, we would put a -4 in our little box. And then we would have 1, -7, and 2. We bring down our 1. -4 times 1 is -4. -7 plus -4 is kind of like -7 minus 4 would give us -11. And then -4 times -11 gives us a positive 44, which means we have a remainder of 46. So then to write our final answer, since we started with an x squared here, this is going to be an x minus 11. And then if you guys remember with our remainder, we would do plus 46 over what we divided by, x plus 4. And that would be our final answer. And that's kind of our review of the basic operations with functions with that new notation. And the reason we're introducing this new notation is because now we're going to start talking about composition of functions, which is just another way that's not adding, subtracting, multiplying, or dividing, of combining functions together. And the notation for this looks like this, is when we use that little O right here. It's like a little open circle, and we kind of say it as f of g of x. So the way we kind of say it as is f of g of x. So you're going to hear me saying that a lot. It's not the same as multiplication, even though it kind of looks like a multiplication sign. It's not the same. It's almost kind of like we're evaluating the function f of x with g of x. Like we're treating g of x like it's a number, and we're going to plug it into f of x, or vice versa, because we can also find g of f of x. We can also find g of f of x or g of f of x. And you're going to see me use this notation a lot because it kind of makes it more visual for me anyway, so hopefully it does the same for you. So let's just kind of see how this works in examples, all right? So hang in with me, follow along. Let's see how this works in an example. Okay, so for this first example here, we're only going to find f of g of x here because to kind of save us some time, we're only going to focus on this guy right here. And we're going to work with ones that exist for the most part in this class, so you don't have to worry about that. And basically, I'm going to rewrite it as f of g of x. We're going to plug g of x into f and see what we get. And our answer is actually going to be more like a list for this type of example. So to start, I'm going to find f of, well, the first g, x of g is going to be 8. So f of g of 8, well, g of 8 is 15, right? Because the solution, the answer is the y. We're going to plug in the x, our answer is the y. So this becomes f of 15. Well, then we come over here to our list for f. Well, when I plug in 15 to f, I get 11. So f of g of 8 equals 11. And we're just going to go down this list. F of g of 5, well, g of 5 is 1. F of 1 is 8. And I'm going to keep going down my list here. F of g of 10, and I'm just using the x values right here. That's where I'm getting these numbers. F of g of 10, well, g of 10 is 14. F of 14 is 9. And my last one here, f of g of 9, well, g of 9 is 0, and f of 0 is 13. So our final answer would be that f of g of x equals, well, we would have 8 comma 11, right? Because we have 8 comma 11. We would also have 5 comma 8. We would have 10 comma 9. And we would have 9 comma 13. And this is our other way of combining functions using composition of functions. So let's go ahead and try this again. If you want to pause the video and try it on your own, you can, or if you just want to follow along, totally okay. Again, we're just finding f of g of x. Right here, you guys can see that we're just finding that. So I'm going to start with the g, start with my first x here. So I have f of g of 4. Well, g of 4 is 3, so I have f of 3. Well, f of 3 is negative 2. Move down my list over here. F of g of 2. Well, g of 2 is negative 1. F of negative 1 is negative 5. And then I have f of g of 9. Well, g of 9 is 4. F of 4 is 7. And then last but not least, I have f of g of 3. Well, g of 3 is 10. F of 10 is 8. So then putting our final list together, we have f of g of x equals, well, 4 comma negative 2, 2 comma negative 5, 9 comma 7, and 3 comma 8. And that's kind of like the basic introduction to composition of functions here. We're not going to do a ton with ordered pairs like this. We're going to focus on functions themselves a little bit more, but this was going to be the easier way to introduce it to you. So now for our next example down here is what we're going to see most often. And we are going to find both of them now. It's a little bit easier to find both of them now, so we are going to find both of them. And we're going to start over here and find f of g of x. So remember, I'm going to rewrite it like this because it's a little bit easier to visualize. F of g of x, well, g of x is 4a. So we have f of 4a, and we're going to evaluate f of x as if it was 4a. So we would have 2 times, everywhere I see an a, I'm going to plug this in, 4a minus 5. Well, right here I can just multiply. 2 times 4 is 8, and have the a minus 5. And that's how we're going to do these composition of functions with functions and not just ordered pairs. And so then if we wanted to find g of f of x, we basically just flip-flop these, and it's going to be g of f of x like that. And we're going to plug f of x in right here. F of x is 2a minus 5. So I want to evaluate g at 2a minus 5. Well, g is 4 times a, so everywhere I see an a, I'm going to put this 2a minus 5. So I know that this is just going to be 4 times 2a minus 5. Okay, distribute there. 4 times 2 is 8a. 4 times negative 5 minus 20. And we just found our f of g of x and our g of f of x. And notice how they're not the same. All right, I want you guys to notice that they're not always the same, so you do need to evaluate both if I ask you to. So let's try this other one together again. See if we can kind of figure out a pattern here. Go ahead and pause it if you want to try it on your own. The first thing I want to find is f of g of x. And basically I'm plugging g of x in to f. Everywhere I see an x, I want to plug in my value for g of x. For this particular problem, g of x is x minus 6. So everywhere I see an x up here, I'm going to plug in x minus 6, and I'm going to use parentheses. So this is going to give me x minus 6 squared plus 2. And this is where these get kind of tricky. All right, this is where it gets a little bit harder. We know that this means we're going to end up having to FOIL. I know that this is actually just x minus 6 times x minus 6. and that plus 2 is there at the end. And I'm going to have to FOIL here. So if I FOIL this, I have x times x is x squared. X times negative 6 minus 6x, negative 6 times x, minus 6x. Negative 6 times negative 6 is a positive 36 plus 2. That plus 2 just stays at the end. Combine my like terms, I have x squared. Negative 6x minus 6x is minus 12x. 36 plus 2 plus 38. And there's my final answer. So that one was a little bit harder because we ended up having to FOIL. And that's the hard here. If you ever have an exponent, like an x squared, an x cubed, that's where it gets a little bit harder. But just think of it as like we're evaluating a function. And when I say evaluating a function, I'm thinking of if I told you to find f of 4, we would just plug the 4 in for x here, right? And do 4 squared plus 2 to get, well, 4 squared 16 plus 2 to get 18. That's kind of all we're doing, but instead of having a number here, we're using a function. So it's a little bit harder, but it's kind of the gist of it still. So let's go ahead and find the opposite here, g of f of x. And we know that f of x is x squared plus 2, so we're finding g of x squared plus 2. And so then whenever I see an x over here, I'm going to plug in an x squared plus 2. So this changes to be x squared plus 2 minus 6. And this one's much easier than the last one. All I can combine is this 2 and minus 6 right here to get x squared minus 4. And that's where we would stop there. So I have one more example for you guys to do, and I want you guys to try to do it on your own. So why don't you guys go ahead and pause the video and try this last example on your own. We kind of have one of each. And for this first one, only do g of f of x. All right, only do it this way. So then you'll just start with finding the values for f right there. So pause the video and try this on your own. Okay, so for number 3, first thing I want to do if I'm finding g of f of x is I'm going to find g of f of 2, since 2 is right there, which is just going to be g of, well, f of 2 is 5, so g of 5 equals 8. So then I have g of f of 6, f of 6 is 10, g of 10 is going to be 13. Keep moving along here, I have g of f of 12, f of 12 is 9, so I have g of 9, which is 11. And then I have g of f of 7, f of 7 is 6, so g of 6 gives me 15. So my final answer for g of f of x is going to be the list of ordered pairs. So I have 2, 8, I have 6, 13, I have 12, 11, and I have 7, 15. And that would be my answer there. And again, we're going to focus more on these function ones like this down here, but that's how you would do it with ordered pairs. So the number 5, we're going to find both f of g of x and g of f of x. So let's do f of g of x first. So I'm going to have f of, well, g of x is 5x minus 6. So then everywhere I see an x up here, I'm going to plug this in instead. So this is just going to be negative 3 times 5x minus 6, which I would just distribute the negative 3 in to get negative 15x plus 18. So then to do the other way and find g of f of x, well, f of x is negative 3x, so I have g of negative 3x, and then I'm going to plug that negative 3x right there for x to get 5 times negative 3x minus 6. I I just got to do a little multiplying right here to get negative 15x minus 6, and there's your answer there for g of f of x. So I know this was a little confusing, but try your best. Here's your homework assignment here. This is 27 through 33 odds. 27 through 33 odds on page 390. Again, these notes will be posted on Classroom, so you can go back and look at them for examples. You can find other videos on YouTube to help you solve it. Just search for composition of functions. And that will help you look as well, because that's what we're doing here. And I should give you some more examples. Don't worry about domain and range on any of the problems in the textbook, and email me if you have any questions.